Okay, in this section, let's start with the example of determining the module, phase width and pitch diameter of the gears. Diameter of gears. So, for pair of spur gear having 20-degree inverted fold depth width is to be transmit 12 kilowatt power at 300 rpm opinion between the gears, and the speed ratio is 3:1. Interior of the cast iron material of the gear is cast iron. That for pinion is steel. The allowable static stresses for the gear and pinion are 60 megapascal and 105 megapascal respectively. The pinion has 16 number of teeth, face width 14m. 14m means 14 module. The velocity factor which is given c equal to 4.5 upon 4.5 plus p is a velocity, and tooth form factor y equal to 0.154 minus 0.914 t, that is number of tooth. Okay, first of all, before solving this problem, we have to write down the given. What is given in this question? So given is the 20 degree with the pressure angle of both the gears is 20 degree. The power transmitted by the gear is 12 kilowatt, having pinion speed equal to 300. So we write it here. Pressure angle phi equal to 20 degree. Power transmitted by each of the gear is 12 kilowatt. Pinion speed 300 rpm, and speed ratio is G equal to 3:1. And the material of the pinion and the gear having allowable stress sigma OP means allowable bending stress for the pinion equal to 105 megapascal, and sigma OG means allowable static strength for the gear is equal to 60 megapascal, means 60 megapascal. So first we calculate the pitch line velocity. Pitch line velocity, as I already discussed, that equal to pi dn upon 60. This pitch line velocity is same for the gear and pinion, so we are calculating for the pinion because the speed of the pinion is given here. Okay, write down pi dp means pitch circle diameter of pinion multiplied by speed of the pinion divided by 60 equal to, if we write dp equal to mtp, m because mod m equal to mod equal to diameter upon number of tooth, pitch circle diameter upon number of tooth, and np is written as np. Okay, next we write pi mtp, number of tooth on pinion equal to 16 multiplied by speed of the pinion equal to 300 or 60, so it comes out to be 0.254 module meter per second. Okay, the next, assume surge factor is 1. There is no condition whether load is acting dynamically or not, so we assume 1, and power is given is 12 kilowatt power, so we can find out easily at tangential to load P effect equal to P upon pitch line velocity into surge factor. So P is given as 12 kilowatt, so we can write it here 12 multiplied by 1000, and pitch line velocity V equal to 0.251 m. M represent module, and surge factor is 1, so overall it equal to 48.7 to 10 to power 3 upon m. Okay, and the velocity factor given as CV equal to 4.5 upon 4.5 plus V, as it is given the problem, so we can write it here 4.5 upon 4.5 plus pitch line velocity 0.251 module. Okay, the next one, what we have to calculate the tooth form factor y for pinion and both for the gear. For pinion equal to yp, for the gear equal to yg. Okay, so yp it is equal to 0.154 minus 0.912 upon t. tp means number of tooth on pinion, which is equal to 16, so becomes 0.097, and for the gear it becomes tp replaced by tg, and t is equal to 48 because the speed ratio is given as 3:1, because speed ratio is given as 3:1, so number of, if Tg which is equal to Tg upon Tp, Tp is equal to 16, then Tg will be 16 into 3 equal to 48, so it becomes 0.135. Now calculating deciding factor for pinion and gear, then sigma OP multiplied by yp, allowable bending is for pinion and tooth form factor for pinion. It becomes 105 multiplied by 0.097 equal to 10.097. Okay. And for the gear it is equal to 60 multiplied by 0.13. So we see here that the deciding factor for gear is smaller, so gear will be weaker, hence gear need to be designed. So we design the gear. For design the gear, it means Lewis equation will be applicable for the gear. For gear, WT equal to sigma W into CV into B pi m y. If we write equal to sigma W equal to sigma OG CV in a bracket B pi m y. Put it here, value of WT 47.8 multiplied by 10 to the power 3 upon m equal to sigma OG 60 CV 4.5 upon 4.5 plus 0.251 module multiplied by face with given as 14 module pi m and yg. For solving this, we find and third order cubic equation. Now solving this, we can get module equal to 5.6. So we take it 6 module. Okay. When we find module, we can also calculate the face width equal to 14 times module. 14 multiplied by 6, it becomes 84. Next thing, physical diameter of pinion, MTP. M module, it is number of teeth, 6 multiplied by 16 equal to 96 unit. And physical diameter of the gear, MTG, 6 multiplied by 48 equal to